We live our lives on what feels like solid ground. We walk on the surface of our planet, Earth, a giant sphere spinning in the vastness of space. We feel the firm earth beneath our feet. We feel the push of the wind on our faces. We feel the steady pull of gravity holding us down. This is our everyday reality, a world governed by familiar forces. To move from one place to another, we must push against something. We push against the ground to walk. Our cars push against the road. Even airplanes push against the air to fly. This is the classical world, friction and effort. Think of it like this. Imagine walking on a sandy beach. With every step, your feet sink into the sand. You must expend energy to pull your feet out of that sand. The sand creates resistance, friction that makes the journey harder. This is a simple analogy for how motion works on Earth. We are always moving through something: the air, water, or even the fabric of space-time itself. This constant resistance is a fundamental limitation. It costs energy and limits our speed. Now imagine a different way to travel. What if you did not have to walk on the sand? What if you could float just a millimeter above it? Suddenly the resistance would vanish. Your feet would not sink. You could glide forward with almost no effort. This is the core of a new idea. Instead of a solid ground, imagine a hidden fabric, a grid. If we can understand the grid, we might learn to rise above it, leaving friction behind. This idea changes everything about travel. The ground is the old way, pushing and struggling. The grid is the new map, not bound to the surface of reality. It suggests the rules of motion we know might not be the only rules. We are not just seeking faster travel from A to B. We are challenging what it means to move, to exist, to explore. This is the journey from the ground to the grid. On Earth, every single motion is a negotiation with resistance. When you throw a baseball, you are not just fighting gravity, which pulls it down. You are also fighting air resistance, a form of friction that slows the ball's flight through the atmosphere. This is why a smooth, aerodynamic shape travels farther than a rough, clumsy one. We have become masters of managing this friction, designing sleek cars, sharp-nosed jets, streamlined ships, but we have never truly escaped it. We are always, in a sense, swimming through a thick medium that saps our energy and holds us back. This experience of being in a medium extends to a much deeper level than just air or water. Modern physics gives us a profound idea: the Higgs field. You can think of the Higgs field as an invisible, universal ocean that permeates all of space. It is everywhere. As particles move through this cosmic ocean, they interact with it. And this interaction is what gives them their mass. A particle with a lot of mass is like a person trying to wade through deep, thick mud. It is hard to get it moving, and it is hard to stop it once it is going. This property, this resistance to a change in motion, is what we call inertia. So, when a rocket fires its engines to escape Earth's gravity, it is doing something incredibly difficult. It is not just pushing against the planet, it is pushing against the very fabric of reality that gives it mass. It is trying to accelerate through the Higgs field, this cosmic molasses that resists its every effort. This is why space travel requires such an immense amount of energy and fuel. We are fundamentally fighting against our own inertia, a property given to us by our constant immersion in this invisible field. We are, in every sense of the word, earthbound. The dream, then, is to find a way to change our relationship with this field. Instead of swimming through it, what if we could somehow skim its surface? Imagine a water beetle that can skate across the surface of a pond. It does not have to push its way through the dense water below. It glides effortlessly on top, barely touching the medium that would otherwise drag it down. If we could achieve a similar feat with the Higgs field, we could fundamentally alter the nature of mass and inertia for a spacecraft. It would be like becoming weightless, not just in space, but from the very property of mass itself. The idea of the grid goes even deeper than the Higgs field. The fabric of space is not a calm, placid sheet. Even in the most perfect vacuum, what we call empty space, there is a wild and constant activity. This is the world of quantum mechanics. At the tiniest subatomic scales, space itself is fizzing with energy. Pairs of virtual particles pop into existence and then annihilate each other in fractions of a second. This constant, roiling sea of energy is sometimes called zero-point energy or subatomic fluctuations. It is the baseline hum of the universe. Think of the grid as a vast, invisible ocean. These subatomic fluctuations are like the tiny, choppy waves that cover its entire surface. They are everywhere, all the time. For most objects, like you or me or even a planet, these tiny waves are too small to notice. They average out, and we feel nothing. But for a craft designed to interact with the fundamental fabric of space, these fluctuations would be like a constant, bumpy ride. It would be like trying to sail a tiny boat through a choppy sea. The waves would constantly push and pull on the hull, creating a form of quantum drag. This constant vibration of the grid is a key part of the puzzle. It is not just passive background noise. It is an active, energetic part of the universe. These fluctuations represent a texture, a grain to the fabric of space-time. If you are moving through the grid, you are constantly bumping into these tiny bursts of energy. This interaction could be seen as a fundamental source of friction, a resistance that exists even in the emptiness of deep space. To achieve truly effortless travel, a craft would not only have to deal with its own mass, but also with this constant quantum jitter. This leads to a beautiful and elegant thought. If we could rise above the grid, we would be isolating ourselves from this subatomic choppiness. Imagine a hovercraft gliding over a rough, stony beach. The vehicle floats on a cushion of air, and the bumps and jolts of the stones below are no longer felt. The ride becomes perfectly smooth. In a similar way, a spacecraft that could detach from the grid would no longer be buffeted by the constant storm of subatomic fluctuations. It would glide through a perfectly calm reality, experiencing a smoothness of motion that is impossible to achieve within our current understanding of physics. Putting these ideas together paints a radical new picture of motion. The three key parts are Higgs field subatomic fluctuations concept of detaching. The Higgs field gives objects their mass, creating inertia. The subatomic fluctuations create a textured, bumpy grid that causes a form of quantum drag. If we remain embedded within this system, as we always have, we are forever bound by the laws of friction and inertia. We must always push, always expend energy, always fight against the very fabric of the cosmos to move. The revolutionary idea is to stop fighting. Instead of pushing harder, we could learn to step away from the fight altogether. Detaching from the grid means creating a localized bubble of space-time around a vehicle where the interaction with these fundamental fields is changed. Inside this bubble, the ship might not feel the full effects of the Higgs field. Its mass and inertia could be dramatically reduced. It would become like a ghost, able to accelerate and change direction with an astonishingly small amount of energy. The heaviest spacecraft could become as nimble as a feather in the wind. Furthermore, by detaching, the craft would also be shielded from the chaotic sea of subatomic fluctuations. It would no longer be tossed about by the quantum waves that make up the texture of the grid. The journey would not just be low energy, it would be perfectly smooth. This eliminates two of the greatest barriers to interstellar travel at once: the immense energy needed to overcome inertia, the fundamental resistance or drag imposed by the vacuum of space itself. It is a complete paradigm shift, moving from a brute force approach to an elegant, subtle one. This vision of travel is one of sublime efficiency. A ship that has detached from the grid would not need massive rocket engines burning tons of fuel. Instead, it might use sophisticated fields to maintain its bubble of separation. Once moving, it would continue to glide forward effortlessly, without friction, without inertia, without resistance. It would be the ultimate form of coasting. This is not about breaking the laws of physics, but about finding a clever loophole within them. It is about understanding the system so well that we can step outside of its most limiting aspects and travel in a way we once thought was impossible. The journey of science is a journey of changing perspective. We once believed the Earth was the center of the universe. We then learned we were on a planet orbiting a star. We thought space was an empty void, and now we see it as a vibrant, active fabric. The concept of the grid is the next step in this journey. It asks us to stop thinking of ourselves as creatures stuck to a surface forever pushing against resistance. It invites us to imagine ourselves as pilots who can learn to lift off from that surface and glide above the fray. This is more than just a theory. It is a new direction for our curiosity. Higgs field, zero-point energy. Scientists at places like CERN are probing these concepts every day. The challenge now is to move from observing these phenomena to interacting with them. Can we build a device, no matter how small, that can locally alter its interaction with the Higgs field? Can we measure a reduction in inertia? These are the questions that will drive the next generation of experiments and could lead to breakthroughs we can barely imagine. The practical implications are staggering. A technology that allows us to detach from the grid would not just revolutionize space travel, it would change everything. Transportation on Earth could become silent, efficient, incredibly fast. Energy generation could be transformed by tapping into the zero-point fluctuations of the vacuum. It represents a level of mastery over the physical world that would elevate our entire civilization. The friction that has defined our existence, the struggle, the effort, the constant push against resistance, could become a thing of the past. The one clear idea to hold in your mind is this: we have always been swimmers fighting the current in a cosmic ocean. Now, we are learning that we might be able to build a boat that does not just float in the water, but one that can lift itself above the waves and glide on the wind free from the drag that held it back. This is the promise of traveling above the grid. It is a future where we no longer walk on the ground of our limitations, but instead navigate by a new map toward a horizon of limitless possibility. In quantum physics, we travel above the grid. On Earth, we travel above the ground, yet feel gravity. In space, the vacuum teems with fluctuations. That is the grid. By detaching from the grid, a reverse vacuum space field, we slide across the top of space-time instead of wading through it. Friction and inertia fall away. This is the changing of classical physics to modern advanced physics, from ground to grid, from struggle to smooth, from limitation to possibility.
Touch a whispered prayer, echoes of goodbye, they haunt my nights. Every tear I shed reflects our fight.
Space isn't a neutral void. It's a reactive polarity field, where the vacuum itself carries a negative charge against the positive matter of stars. This creates the dark grid, a foundation where similar positive matter stays separated, much like repelling magnetic poles. By mimicking this zero-point polarity, a ship can achieve zero mass, escaping the limits of inertia and time dilation. The Hubble anomaly isn't dark energy. It's the negative vacuum field absorbing the decay energy of the aging universe to fuel its expansion. Classical physics sees space as a passive stage, but quantum physics theory reveals it as an active, reactive participant. Infinite mass is reincorporated into a weightless condition that applies to all matter, from the smallest atoms to the largest stars. Energy never truly disappears. It flows into the vacuum, expanding the cosmic capacitor. So, who is right? Relativity or the field?
Some physicists believe time is an illusion, a man-made measurement, like a ruler for length. In Einstein's relativity, the universe is governed by a universal speed limit. Nothing can travel faster than light. Approaching light speed, Einstein believed time slowed, eventually stopping at the limit. However, physicist Rodney Koecki has discovered that space is layered with subatomic particles deep in the space grid. In the Higgs field, a superluminal vessel can travel without resistance, as energy is preserved during vacuum acceleration. This enables the Alcubierre warp bubble, forming travel corridors that separate the ship from grid resistance. Two warp drives can make superluminal travel possible, opening a revolutionary future for space exploration. We are moving beyond relativity into a new era of space research.
Think the speed limit of light is unbreakable? Not exactly. While nothing can move through space faster than light, there's a loophole: the space itself. Imagine the universe as a road that's growing. Einstein's rule says no car can exceed light speed, but there's no limit to how fast the road itself can stretch. Distant galaxies are carried away by this expansion. Beyond the Hubble sphere, they actually recede from us faster than light. They aren't breaking physics, they're just riding the wave. This is the core of the Alcubierre warp drive, expanding space behind a ship and contracting it in front. You sit still in a bubble while the fabric of space surfs you along. We can't travel faster than light by pushing a ship, but we can be carried if the space we're on is moving, ready to dive into what dark energy is and why this is speeding up.